Good day, Puan Azrin. My name is Siva and my matrix number will be 01DEM22F1054. So today, me and my teammates will be presenting EOC1, which is about hardware interfacing 5. So I will be reading the introduction. Embedded system application plays an important role in many industries, providing customizable functionality to fulfill unique needs. Among the several hardware interface choices available, connecting a microcontroller like the PIC16F877A to an LCD is a crucial component for many applications. This hardware interface focuses on building such an interface which uses the PIC16F877A microcontroller to show a predetermined sequence on an LCD 16:2 display. The sequence begins with the message DJM F0122 embedded system application, followed by the group name, which will be group Vignesa.Sharven, Melvin, and Siva. And we will be group 4, and then the full screen scrolls continually for a defined length before coming to an end. This report will detail or in simple terms explain the procedure, including hardware setup, software implementation, and a flow chart to demonstrate the operation.
Hi, my name is Sharvindraj Nalagi Balamurgan. My matrix number is 01DEM22F1065. Today I'm gonna present about the theory of our hardware interfacing 5. So the embedded systems are specialized computing systems that perform certain functions within a larger system. They are often made up of a combination of hardware and software components that have been adapted to the application specific needs. Several principles involving theories are involved when connecting to a microcontroller like the PIC16F877A with the LCD. First of all, microcontroller fundamentals. The PIC16F877A microcontroller is a popular choice for embedded systems due to its flexibility and features. It combines a CPU, memory, and several peripheral ports on a single chip, making it appropriate for managing external devices like LCDs. Secondly, LCD interfacing. The liquid crystal displays, which is known as LCDs, are popular for visual output in embedded systems due to their low power consumption and readability. Interfacing an LCD with a microcontroller establishes communication protocols such as parallel or serial interfaces and transferring commands and data to control the display. Next, character display. LCDs can show text and graphics. In this situation, the emphasis is on showing characters which are normally organized in rows and columns. Each character is represented by a distinct pattern of pixels, and the microcontroller sends commands and data to the LCD to display the characters. Moving on to the next one, scrolling text on an LCD. Creates a dynamic effect by continuously changing the display content. This can be accomplished by altering the location of the display characters horizontally or vertically at predetermined intervals. This projects text glides horizontally from right to left. Lastly, timing and control. Timing is critical in managing a system's action, such as the length of the scrolling test when to stop. The microcontroller uses inbuilt timers or software delays to manage the timing of events, ensuring that the desired sequence is executed correctly. Moving on to the flowchart of hardware interface. First of all, we need to start it. Then initialize input and the output. Then it will display DJM 50122 embedded system application on first line. Then on second line, group name, which is Vignesa.Sharven, Melvin, and Siva. Then the whole screen starts to scroll to the left, and it will be delay for 5 seconds, and then it will stop, and finally it will be end. That's all from me. Thank you.
So hello, my name is Melvin Jude, Alaki Vincent John, and my matrix number is 01DEM22F1059. So I'm going to talk about the procedure. So there are 5 procedures. So as first of all, you can see hardware setup in Proteus 8. Launch Proteus 8 software and create a new project. Search and place the PIC16F877A microcontroller and LCD module from the component library onto the workspace. Wire the components together according to the desired hardware setup. Double-click on each component to configure its properties, including pin connections and parameters. Second, software development in MPLAB IDE 8.8.5. Open MPLAB IDE 8.8.5 and create a new project for PIC 16F877A, a microcontroller. Write the program code in C language to interface the microcontroller with the LCD module. Include necessary libraries and functions to initialize the LCD, control display, and implement scrolling functionality. Then compile the code and generate the hex file or soft file of the compiled code. Thirdly, combine hardware and software. Load the hex or soft file generated by MPLAB IDE 8.8.5 into the simulated PIC16F877A microcontroller in Proteus 8. The fourth, simulate the project. Run the simulation in Proteus and observe the behavior of the microcontroller and LCD module. Verify the starting message, group name, and scrolling tests that are displayed correctly on the simulated LCD screen. Debug any issues encountered during simulation using Proteus debugging tools. Fifth, testing and troubleshooting. Test the functionality of the simulated system, ensuring that the scrolling text stops after the specified duration, which is 5 seconds. Troubleshoot any issues that arise during testing, such as incorrect display, erratic behavior, or timing errors. Last, use MPLAB IDE 8.8.5 debugging tools to debug the software code if necessary, ensuring correct functionality. Last but not least, documentation. Document the entire process, including hardware setup in Proteus 8, software development in MPLAB IDE 8.8.5, simulation, testing, and troubleshooting. Also include screenshots or recordings of the simulated LCD display during the testing. Last, record any observations, debugging steps, and optimizations made during the simulation process. That's all from me. Thank you.
A very good day, and my name is Vignesa with the matrix number of 01DM22F1063, and today I'm going to present about schematic diagram 5.0. So as you can see in the schematic diagram, there is not much components. There's only 3 main components, which is the power component, the PIC 167788, and with the LCD. Alright, so do mind me if I told the wrong PIC number, but I'll correct it in right now. So actually it's PIC 16F88778. So sorry about the mistake, huh? So let's move on to 6.0, which is MPLAB IDE 8.8.5 programming, where in this part the libraries that we use is really important, such as include pic.h and include string.h, which is used for the start function, and to define the ports, to define RS, RW, and EN, which is one of the ports, 3 ports inside the LCD. We have to define it in which port that we're going to connect it, and in this case we have defined the RS at RCO 0, RW at RC1, and EN at RC2. And then moving on, we have void LCD, CMD data, init, initialize, delay, and scroll left, and then going back to void main, TRISC, TRISB. TRISC is about defining the RC0, RC1, RC2 as output, and also TRISB is port boot as an output for the data lines that we are going to come out on the LCD, the DGM 50122 embedded system application with the group name. So that's in TRISC, TRISB, sorry. And then moving on to the codings down there where I have defined message. All right, message 1, message 2. So message 1 is where I define it as a DGM 50122 embedded system application. Message 2 is group Vignesa.Sharven, Melvin, Siva, and group 4. So message 1 is the first line which will pop up in the LCD screen. Message 2 is the second line that will pop up in the LCD screen. Okay, so let's move on. So displaying is done, and now we move on to the part of scrolling. So the words have scrolled to the left. So with that, we have to make command where it needs a delay of 5 seconds when the scrolling is happening. So for 5 seconds, the scrolling has happened, and after 5 seconds, it has to end. So we have to define the processing time of the movement of the the words in the LCD. Okay, so I have a couple of written codings here that defines and pretty much tells on how to make the first line and second line scroll to the left in 5 seconds. And with the proper words and numbers put onto the codings, we will get a proper scrolling to the left in 5 seconds delay. So that's it, and that's about the programming section. And now we move on to the Proteus simulation, which is 7.0. So I have attached a few pictures here to give a better picturing about what happens. So in the first picture, you can see the first line and second line has been completed. We can see the full version of the first line message and the second line message. So it is shown in the second picture where it is on its way scrolling, and this is the second part of the scrolling. The first picture was the first part of the scroll, and the second picture is about the second part of the scrolling. And then moving on to the third picture where you can see the last bits of the scrolling of message 1 and message 2. And then in picture form, the program has ended. That means it's completely empty on the LCD. Okay, and this only happens after 5 seconds. Alright, the scrolling of 5 seconds. And that is all from me. That is all I have to explain about 5.0, 6.0 and 7.0. Thank you very much.
Okay, to sum it all up, the successful integration of a PIC 16F877A microcontroller with an LCD module accomplished through the use of MPLAB IDE 8.8.5 for software development and Proteus 8 for hardware simulation demonstrates the effective application of theoretical concepts in embedded system design. By overcoming obstacles like debugging mistakes, wiring discrepancies, and timing complexities, this project demonstrated the precise execution of essential principles such as microcontroller operation, LCD interfacing, and text scrolling. The simulated system displayed the preset message and scrolling text consistently after through testing, and displayed the preset messages and scrolling text consistently after through testing and debugging, confirming the robustness of the produced software code and the accuracy of hardware setup. This effort not only demonstrates the symbiotic relationship between theoretical understanding and actual execution, but also emphasizes the need of exploiting integrated software hardware platforms. This endeavor not only demonstrates the symbiotic relationship between theoretical understanding and practical implementation, but it also emphasizes the importance of using integrated software hardware platforms for efficient development and validation of embedded system solutions, paving the way for future innovations in the field. That's all for now. Thank you.